right, I assume everybody can hear me. Do I need to talk a little louder? Are we good? Yeah? All right. Great. Hi, everyone. I've met some of you before, but I'm Andrew Cassell, PHP developer. I've been developing for about 10 years. I'm kind of local here. I live in Herndon, which is about 10 miles away, or approximately 8 days travel during DC rush hour. We're for a nonprofit that's called the Marine Spill Response Corporation, and we clean up oil spills. We're a nonprofit. We're the largest in the United States that does what we do, and we have all kinds of equipment and people who are trained if there's an environmental disaster to respond. I work, like I said, at doing PHP development there. I do mostly applications. We also build their website, and I work as a part of a 3-man team. So 3 developers, small team, but I would put our 3 developers up against a team of 10 any day. I'm also the organizer of DC PHP, so if you're local, we'd love to see you at our meetups. Today, hopefully, it's going to be a lot less formal than most presentations. This is a workshop, so I intend it to be interactive. The video is going to be recorded. If you guys need to refer to the slides later, I'll put them up on the Joined In. I'll also post them. A link to Twitter. Joined In is the conference rating system that you guys should rate this talk afterwards. So the video the slides are going to be recorded, but nothing is going to be video recorded. So you guys don't have to worry about being up on camera or anything like that as we do stuff together here. I'm going to be kind of presenting here for a little while, then we'll do some work, and then we'll present a little bit and do a little work again. But while I'm presenting, because I want to try to keep this informal, it's kind of a small enough group we can do this, just raise your hand, and if you have a question, I'll stop and try to answer your question and stuff like that. I really don't want to go any further unless you're not, you're understanding something. So for today, you can assume that all the code you're going to see and do is PHP 7 or 7.1. But that doesn't mean you can't use PHP 5. I've been doing this longer than PHP 5 is what we did it for a long time before PHP 7 came out. So all of the code that the examples and stuff you're going to see, the only differences will be type hinting on the returns and stuff like that you'll see from PHP 7. But other than that, nothing changes to go back to PHP 5. We're also going to take a break in the middle, right around 11 when the other session gets out. Just you guys use the bathroom, get another cup of coffee or whatever. Also, as we're doing exercises, if you need to leave, whatever, that's fine too. So, to get into, why are we here today? Why are you here? Why am I here? Because I'm here for the same reasons. I want to become a better developer. I want to be a better resource for my organization. I believe in becoming a craftsman, meaning having better code craftsmanship, raising the level of my code, and becoming a more mature developer. And becoming a more mature developer means better understandings of the problems that you're trying to solve. Becoming more of a value for the company that you work for or for your customers. One of the best ways that I know to become a better developer is through domain-driven design. And domain-driven design, it's often referred to as DDD, and the cool kids on the street call it that. But it's a very, very large topic, and there's no way I can teach you everything in about 2.5 hours we have today. But I'm going to try to show you what I think are the fundamentals and insights that everyone can benefit from hearing. So, anytime a presentation starts with a survey or a definition, I immediately hate it. But I am going to start with a survey and a definition because I want to kind of gauge this, because it's going to be kind of a workshop. I want to know a couple of questions here. So, does anybody know DDD? Or has experience with DDD at all? One person. Okay. 2. Okay. You've read it. Okay. So this will be fun. It's going to be a very beginner introduction. I think it'll be good for you. And then I'm going to give you a ton of resources at the end, so you guys can go and learn more. And I'll obviously answer questions. So let me tell you what DDD is not. It is not drink, drive, and develop. But we are going to be talking about beer today, so please drink responsibly and code responsibly. No, so today's workshop is on common sense software development. And when I mean common sense software development, I mean, doing things that make sense, as it says. As every presentation should, steal a quote from Steve Jobs, design is not just what it looks like and feels like. Design is how it works. If you look at the circuitry of an Apple computer, the old ones, they're beautiful compared to most computers of the time. And your code should be beautiful too. There's not much more effort to be put in order to make your code more presentational. So because software to me is first and foremost about problem solving. Now, Freddy Krueger is an excellent problem solver. He is designed to kill and is very effective at it. But what I'm saying is people will enjoy your software much more if it's more like James Bond. Still designed to kill people, okay. But you're going to want to hang out with James Bond at a bar more, and drink a martini and things like that. So you want to get the job done, but do it in an aesthetically pleasing manner to both you and your clients. So the bulk of the information I'm going to talk about today are from these two seminal books on domain-driven design. The first one, Domain-Driven Design, was a book by Eric Evans. He wrote it in 2004. You can kind of think of this as the Old Testament of domain-driven design. The first time I read it, I did not understand it at all. Maybe I'm a little dense, but it's a very, very theoretical book. But once you understand more of the experimental side of things, and you go back, it makes a whole lot more sense. The second book was by Von Vernon. People call it the Red Book, kind of the New Testament of domain-driven design. And this goes into a much more practical application of how to build your code using domain-driven design. There's been plenty of books afterwards once everybody got on the gravy train of domain-driven design. If you want to learn more about the techniques and things like that, or if you were like me in high school and just read the Cliff Notes, the domain-driven design books on the end in PHP and domain-driven design quickly, those were good source material to get going quicker. But first off, like when I'm talking about the code and patterns and stuff like this, none of this stuff is new. Nothing that the domain-driven design people created was new. It was all looking at patterns that had already existed in software development for a long time, whether that's repository patterns and object-oriented programming, things like that. And most of this comes from books that are even older than the books that I just talked about. A couple of people that I want to thank real quick from the PHP community is Matthias Reyes and Bo Simonson. They've been fantastic pushers of DDD and PHP, and couldn't do this presentation without them. Okay, so for those of you who haven't heard about domain-driven design, this is your definition. So if you read the Wikipedia definition of it, you kind of get an idea. DDD is about focusing on the core business problems that you're trying to solve, developing a valuable collaboration with the other people who have a stake in the process or in the project that you're building, and then trying to model the objects in your software in a way that is both understandable and maintainable. So DDD is really meant to help you tackle really complicated problems, much like putting together IKEA furniture, but for software. So we're going to be trying to figure out the model, how to model what the business is trying to do it, and then figure out how to apply that model to code. So if you don't have a good grasp on object-oriented programming so far, I apologize. But this is going to be very object-oriented heavy. And when I mean object-oriented programming, I don't mean how they teach you object-oriented programming about how dogs drive and cars bark and those kind of things. This is object-oriented programming how it was meant to be. If you go back and read some of the older books on object-oriented programming from Smalltalk and things like that, this is where the DDD people read this and applied it to new software practices. So to summarize, DDD, we're going to be talking about encapsulation, so encapsulating business rules and things like that in logic. Immutability, something that's going to make your software much easier to maintain and write. Modeling, so we're going to talk about modeling objects and entities and stuff like that. And behavior, and encoding the behavior of the business or the process that you're trying to model into your software. So when I say the word domain, I'm talking about the problem we're trying to solve. So, or the problem space is kind of a universal word in the sense that it's either the problem or this problem space. So for me, my domain is oil spill response, but that's probably not very exciting to you guys. So we're going to talk about something I'm much more excited about, which is beer. So I'm sure many of you have been to a brewery. Do any of you homebrew or know how to brew beer? Great. So we had at least a couple of domain experts in the room here. I've been brewing for 15 years, and I'm 34. So do the math. I found out you could buy all the ingredients in college, and they don't stop you. So we're gonna try to model the process of doing a brewery. I sent you all a handout out. It's got some stuff in it about brewing and whatnot. But my first job out of college, in college still, as a co-op, was in the beverage industry. I worked for a company that built high-speed packaging equipment for Budweiser and Heineken and stuff like that, and they could package 300 cases of beer a minute. So it's an industry that I'm familiar with on both sides, and so we were writing, and I can't show you the screens that we were writing, but we were writing human-machine interfaces, for those big giant machines. Again, I hope that this presentation is both going to get you wanting to do domain-driven design and brew your own beer at home. But domain-driven design is very safe. You don't have to worry about it. But brewing can be dangerous. There's hot liquids. There's steam, things like that. Please, if you're going to go into it, be safe, be careful. Care about your safety very much. If you want to learn how to brew, first thing is grow a very big beard. No, it's actually not necessary. I can't, but I'm doing fine. There is a book that's out there that's called How to Brew. It's kind of the seminal knowledge that's out there. But on the first page of your handout, I've got this diagram, and you kind of refer to that today, as we do some of the process modeling, things like that. This is my favorite diagram of the brewing process because one, I think it shows you that, the things that are going into the process, but it also has two features that I really like. Is that everything goes through the process of milling the grain and mashing the grain, which is like when you put the grain in at 150 degrees, 158 degrees of water. That's like 65 C if anybody's international or not imperialist. So you put the grain in the mash tun, which is this container right here, and it steeps for like an hour, depending on how long you're needing to do it. You separate the grain from the water, and that's called spent grain, comes out. And then you take the liquid that's left over from the grain, and then that's what you boil. And that's what you throw in the hops, which is what gives beer that bitterness and that flavor. You boil that, you cool it down, you put it in a fermenter, which is either a giant stainless steel vessel or a bucket. You put an airlock on it, so you separate it from the outside environment, so no bad bacteria and things like that get in. You add your yeast, which is usually a brewer's yeast, which you can buy at a shop. And it usually ferments maybe 2 weeks, 3 weeks, depending on what you're making. Some beers you can make at room temperature. Others, like lagers, you need to do cooler. So there's there's a lot of things you can do with this process to make different types of beer. And then usually it comes out of the fermenter into a keg or into bottles and is carbonated either using forced carbonation, or if you add a little bit more sugar back into the beer, you can get it can condition in the bottle, so it can carbonate it. So yeast, when they eat sugar, there's two things that come out. There's CO2 and alcohol, and a few other things. But for the most part, CO2 and alcohol, which is the things we really like. But the reason I really like this diagram is that as the process goes through this way, on one end you get beer, and on the other end of the spent grain you get bacon. So those are two really good things. So just to show you some of the ingredients that this is barley. I've got some of the ingredients up front. You guys can take a look at. Then you malt the barley, as I said. You look a bit closer look. After it malts, it turns brown, a little bit toasted. This is a picture of the mash tun where they're mixing the grain and the water. These are hops. You don't usually see hops in wild in most places, so they're grown in big farms for the most part. That's what a hop looks like. They're about that big or so. And then it goes into the boil kettle. So you can either do loose leaf hops like this, or you can buy it in pellets. So this is boiling the liquid that came off of the grain that was separated from the grain with the hops, and that helps extract some of the flavors and stuff from the hops. And then you cool it down, add your yeast, which is the little bugs, which we want bugs in our beer but not in our software, and then put it in a fermenter, and out comes beer. So and everybody hopefully likes beer. But if you don't, I apologize. These are a couple of beers that I brewed. Why am I talking so much about beer? Well, we're going to be making beer brewing software here today. And there are plenty of examples of beer brewing software. This is one that I use a lot. It's called Brewer's Friend. It's okay. This is a recipe that I made for the conference here. It's the Northeast IPHBA. So we will be, I'm not going to have any during the workshop because I want guys to stay focused, but I did bring some bottles of it with me. I also have my Hefeweizen with me as well, so we can sample that later. There's plenty of software out there already, so we've got some good examples to look at if we need to. Beersmith is probably the most widely used. It is very complicated, and I realize that picture's kind of blurry, but it doesn't matter because there are so many knobs and switches and everything in the software, it's ridiculous. This is supposed to be the easy water calculator. Very, very many fields in an Excel spreadsheet to fill out. This is the not easy water calculator. So when you're putting your water in your beer, you want to kind of adjust various minerals in it and stuff like that to try to figure it out. And you tend to have to use like multiple pieces of software all together. And then people can get 16,000 views on YouTube for how do you use the two pieces of software together because it's really complicated. And I mentioned Brewer's Friend. This is one that I've used that's not terrible. There's another one, a Brewer Wall, that's more like calculations and stuff like that. It's kind of useful. So I've got it in my head the last month or so. I'm going to write a new piece of software, and I'm kind of using it to do some examples here. And I told my wife I need time to work on software, but it's for the conference. Don't it's not for this stupid hobby of mine that costs way too much money. But anyway, so Beeriously is what I'm calling it, and hopefully you learn if you're writing beer software. I don't know if you've seen this XKCD comic or not, but it talks about programming steel with the amount of blood alcohol concentration, and they call it the Balmer peak. So if you get it right around 0.12, you're an excellent programmer. So that's what I would highly recommend everybody try. So that's enough about how the process of brewing and stuff like that. I just want to get you guys familiar with it. But if you're going to build software to manage a brewery, and say that you've walked into a brewery and they've asked you, okay, you're going to build software for you. Now, most developers, when they start thinking about software, they start thinking about the data that the software is going to have. So they're worried about, okay, we're going to need a recipe table because obviously this brewery needs recipes. We need a hop table because we're going to store data about hops and things like that. We need a grain table. We're identifying the data and stuff like that. And that's kind of how our developer reptile brains work. You start thinking about data and the infrastructure and things like that. Okay, we need a hop inventory database. Are we going to use NoSQL or MongoDB? These kind of questions start popping into your head. I don't know if it's the ADD kicking in or if it's just all developers, but I think that's kind of how our brain starts working. We just start flying off the handle. We haven't even thought about the problem we're trying to solve. We're already starting to think table, table, table. What's the events? Oh, we're going to use events, things like that. We have a queue. We need, we're going to get RabbitMQ. How are we going to do these queues and things like this? Maybe if you're a Symfony developer, you're already thinking about, okay, role user, how are we going to do the permissions, things like that. I can't stress this enough, but and this is kind of what the beginning of this presentation is about, is just slow down. Try to understand the problem you're trying to solve. Most of us, and I'm guilty myself, is we don't actually take the time to try to figure out what the problem is. We're all these super intelligent beings that have brains that work at 1,000 kilometers an hour, but you have to stop and think about the problem you're trying to solve. So what I'm saying is that the implementation is important. How you implement your code, what frameworks you use, stuff like that is important. But that's often the first thing we start thinking about as developers, or that's how we identify the developers. I'm a Symfony developer. I'm a Laravel developer. I'm a Zen developer. Now we're here to solve problems. It doesn't matter which one of these frameworks you use. They're all fine, except for one. I'm not going to tell you which one. No, just kidding. See, I could already get people hating me if I just picked one. No. So there's this saying. People don't want to buy a quarter-inch drill. They want a quarter-inch hole. They don't want to hire you, honestly. They don't want to pay you money. Why would they want to pay you money? What they want is they want their problem solved. So you have to identify the problem space. You have to work with the people that you're going to be working for and actually identify, is what you're trying to solve a problem in the first place? Put your, the value that you can give to a company, to the right place. Make sure you're solving the right problems. And remind yourself that unless you work for yourself and your own consultant, which then your money is made in being part of the problem, remind yourself that your job is to make a pile of money or save a pile of money for your company through software. So maybe writing your own DI container, writing your own framework, writing your own session management, doing password resets and stuff like that, and not focusing on the core business problems is dragging the company down a little bit. So really just relying on frameworks to do the things that frameworks do well is very important, because you're going to have enough problems dealing with your own code and dealing with the problems of the business. I like this tweet. I just saw this the other day, so I added it. But despite what newcomers think, understanding a language, framework, or even algorithms is not the hard part of building software. And I agree with that. And I would remind everybody that we're probably all using PHP today. That's probably not going to be the case in 20 years. Hopefully, I still want to be doing my job in 20 years. Might be in PHP, might be another language. You don't know. I mean, the tools change. We've all seen the tools change in our careers, in our lifetime. The practices and how you approach problems, that doesn't change. You get better and better at this, and you learn a method of approaching problems. Your skills can apply to any language or any job. There's a whole methodology of, I don't want to bore you too much, but there's this whole methodology of trying to figure out what is the problem you're going to solve. It's jobstobedone.org, and he has this whole spiel that he does, like a telemarketer or something like that, about milkshakes that you can hire them. But really the whole idea is why is the person using your software Monday at 8 a.m.? Try to understand them and get in their mindset, and not try to just build feature. That may not be actually what they need. Try to understand the problem that they're doing, or the problem that they have, and try to put yourself in their shoes. One way you can do that, and this is from them, the jobs to be done, is the 5 whys. And the problem is here, if the people that you're working for are probably not software developers. They're probably not software designers. So if you show them something and the first thing they see, they're like, wow, that's awesome. You've impressed them, sure, but maybe you haven't actually solved their problems. So what we want to do is go from somebody saying like, wow, that's great, to, of course, that's how it should be. So that's where we want to end up with our software is, of course, that's how it should be. Otherwise, you might end up with a beautiful app, but it delivers artisanal toast or something like that, something silly. We want to solve a real problem here. So an example of the 5 whys, like let's say you walked in the brewery, and I'm going to suggest that you do a drink for every why here as part of the plan here. But say the brewer says, oh, I need a list of grain in inventory. So okay, if you're the quick and easy developer, you're just going to say, yep, I'll give you a list out of the database. Select all, whatever. But if you're thinking, you're going to ask that brewer, well, why do you need this list? And the brewer is going to say, well, because I need to be able to sort the list of grain to see the inventory, to see which one I'm running low on. Well, if you ask him why again, he's going to say, well, because when we formulate a recipe, we need to check and see how much of a particular grain we have on hand. Then I have to figure out, okay, how much do I need to brew that recipe? I'm going to do the little math in my head and figure it out. So at this point, maybe you're thinking, oh, I can build a search mechanism out of that list. I can list the inventory right there. But if you don't keep asking why, you're not actually going to get to a better solution. So if we ask them a why, well, why don't we automatically calculate how much grain is needed to order? On the brewery recipe creation process that's handled by the brewmaster, in the ordering may be a completely separate department. But if you ask the questions why, you might figure out that why can't we just automate the process? Why can't we say when recipes designed and we're scheduled the brew session, we just automatically order the stuff? If you don't ask the why, you start up with what is maybe the simplest solution, it will take you the least amount of time. But you end up with automation and what is real powerful software that's going to save the business tons and tons of time, perhaps tons and tons of money. So DDD, just to kind of phrase it all over, is not about the patterns. It's not about, you're going to hear things about CQRS and event sourcing, all these fancy things in DDD. They don't matter. It's not about adding tons and tons of complexity to problems. If you have a simple problem, keep it simple. So DDD is not for every project. It's not even for every part of a software application, perhaps. We're trying to keep things simple, as KISS, keep it simple, stupid. But so don't use what I'm kind of teaching you here for things that are simple crud. Like you have a data entry form and you need to display that. Like don't bother this, use Laravel or something like that. It's going to be much faster. Don't use it for content sites or websites. Like I said, I build applications for the company I work for. We didn't use DDD at all on our website. A little bit for some of the stuff, like pieces of it, but for the most part, it was just, it's content. It's not worth it. Don't use it where you're doing functional programming, things like that. If you take it to the extreme, you end up with, and this is a great GitHub project to go check out, it's enterprise quality coding, the FizzBuzz Enterprise Edition. I think it solves the FizzBuzz problem in like 8,000 lines of code or something. I can't remember exactly, and just to kind of iterate it, or sorry, to finalize it, the DDD is not the one true way to build software. That is obviously Ruby on Rails. Okay, so all of the normal solid principles apply for doing good code. If you're not have a good grasp on this, maybe spend a little time and read about it. But what we're more concerned about today is the quality of the software. And quality software, if you look at research about what is good quality software, Carnegie Mellon has a great training program for that. We talk about what are the things that make good software good. And I'm going to pick like 5 out of these big giant list of software quality. And that's what I think are the most important. Is correctness, meaning the software works as expected. Testability, usability, maintainability, and modifiability. So, just what I think are the 5 most important things about good software. And we're going to compare a DDD app, domain-driven design app, against your usual CRUD app, what most of us learned how to develop doing. Mateus Reyes, who I mentioned earlier, has a lot of great blog posts, but this is a good one. It's CRUD is an anti-pattern. Designing your software to modify data in a database, but not creating software for behavior will cause you problems over time. People in the DDD world, they don't call it CRUD apps. They have another name for it. It's called the Big Ball of Mud app, and I'll get into kind of explaining that in a minute. But if you were to compare like what kind of apps you should use in DDD, even in a brewery versus CRUD mud, like I said, if you're going to do recipe building and brewing sessions and calculations, that's all going to be good stuff for DDD. The CRUD mud side of things might be the inventory, because it's just, it's basically read, update, and delete. The beer menu, you're just adjusting prices and things like that. It's probably not very important to the business to have good modeling and good practices in place. So who is responsible for this software being good? Who's going to be responsible for this? Well, it's both you and the domain experts, Lord Business here. Or, as we call them, the product owners, the domain experts. So in the brewing case, you're going to be talking to the brewmaster. You're going to be building a software for him or her. That's the person whose problems you're trying to solve. Now, you're going to have to work with that person because, maybe he or she is not, a big software developer, doesn't know what's possible. You guys are all very intelligent, and you know what is technically feasible in software. They don't know what's possible, both from, yeah, that's completely impossible, we could never do that, to, yeah, that's going to take me 10 minutes, and they're absolutely amazed. They have no clue. They're not technology experts. And you also use the internet a lot, so you see, more software, great software. You kind of know what software you like to use, what is good software, what is bad software. But when you're talking to these domain experts, and I like this tweet a lot, and it says, what the biggest strategy in software engineering, talking CRUD to the people you're meeting with. If we open the blue book, which I mentioned was the first book, like in page 24 of it, it's 500 pages. It's roughly a 500-page book. So page 24, you open basically right up after the preamble. The first topic that comes up is ubiquitous language. And ubiquitous language is the ultimate power of domain-driven design. If you leave here today, there's going to be like 2 big things that I'm going to try to focus on. Ubiquitous language is probably the number 1. It's not necessarily the most important, but it's probably the most important. This ubiquitous language is a shared language that your development team and the domain experts agree to speak. Everyone on the same page. Same word, what a word means the same to them and you. The power of DDD here is understanding the business mindset, the language, and solutions. Understanding how the business implements the solutions to its problems. So like I mentioned, that process of brewing beer, if you don't understand that process, you're not going to be able to write software that builds that. If you're just editing fields in a database, You're not actually building software that's going to solve problems. Some examples of language that you're going to try to share with a brewer. Brewers call them sessions or session beers. We have session database sessions, things like that. User sessions and cookies. If we start saying sessions and they start saying sessions, and we're not saying the same word, it's going to be confusing later. This ubiquitous language, again, it's one of those things that, as tools change, when you switch from PHP to JavaScript and stuff like that, this will stick around. This is lifetime guarantee stuff. I mean, once you learn how to use this and apply it effectively, it's going to be a skill that you can keep forever. As Von Vernon says in the Red Book, DDD is primarily about discussing, listening, understanding. It's about discovery, finding out what is going on in the problem, and creating, in your code base, a centralized knowledge for the business. So your code should accurately reflect the business's problems and the solutions to those problems. And you're going to speak the same language. So everything that's in the, how the business works should be in your code. It should be a one-to-one mapping. So what I'm saying kind of is that domain-driven design and the ubiquitous language should be speaking an idiomatic language. So whatever the business calls something is what you should be calling something. I'm guilty of this too, but you have a user table probably in your database somewhere. So you have a user object. Well, they don't call them users. The only people who call things users are drug dealers and developers. They refer to people as brewers or employees or tasters or customers. So, is it really that much hard effort on your part to rename the class to brewer? I mean, it's not that big of a deal. So when you go to talk to them, you're saying the same words that they're saying. I mean, it's so much simpler. Guys, I'm sure aware of David Letterman. He has the top 10 lists. This is the binary version of the top 2 reasons programming is hard: is naming things, cache invalidation, and off by 1 errors. So the end result of this is that the naming things should be really easy. Like, you should never have that problem again. If you understand the business problem, you talk to them and you share the same language, they're pretty much going to name the things for you. You'll be able to apply this directly to your code. So I'm not picking on Laravel at all here. They're fine. But most of us developers have at one point probably written code like this, where you're just pulling stuff off of the database, find or fail, where name equals something, take one, get. Recipe, hops array, contains hop ID. If, we have this if check and this if not right here, this exclamation point. Hops array, attach, hop ID, and then maybe some data, and then you have to save. Now imagine if you showed a brewer this code. Their reaction would probably be, huh? What? You don't take a hop off the hop repo. They go and they get it out of the out of the storage, the cooler. They don't take it and then get it. Like, that doesn't make any sense. The recipe doesn't have a hops array. That's not something that means something to them. They don't attach a hop to a recipe. That's not how they're thinking. But for some reason, we've written code like this, and that's just how we've siloed ourselves in the world. We've completely ignored how everybody else thinks. So kind of, and this is like, it's going to seem to you completely simple, because it is. But when they say to you, we need to be able to add a measured amount of grain to a recipe, you should have a method on your recipe object called add grains. Sorry, pushed the wrong button. You should have a method called add grains or add grain. We need to be able to calculate an estimated that's alcohol by volume for a recipe. They'll say ABV. So, if you need to kind of not remember, you can't remember what ABV is all the time. Maybe they have some, specific words that they use. Put those in a method together. Recipe, get estimated alcohol by volume ABV. Put the words that they're using in your methods and in your objects. We need to know how much winter wheat is in our storage silo number 4. Well, we'll go to the you can say new storage facilities. Okay, that's we have to do that kind of stuff because that's how PHP works. We have to have some constructs and things like that. But they could probably understand this. You look at the storage facilities and find the storage facility by name, silo number 4, and then storage, how much grain of type, new grain type, winter wheat. So they can kind of get this. I think it's starting to get more technical, but it's still much more understandable with somebody just looking at this. Things get much more complicated, in this kind of brewing software, and I'm sure in your software packages, we need to add 0.2 ounces of a 12% alpha acid per gallon of Simcoe hops to recipes at a 7-day after the boil is complete, and that's called dry hopping. So, the bottom here, kind of showing you as things get more complicated, but it's still readable. If you're probably already, your brain's already thinking, but can you imagine this is not very difficult code to write? Like, there's not much change between what I showed you before and what I'm showing you now, but it's all in the naming and how you're going to apply things. And later, when they're like, oh, we want to see how that dry hopping thing works in the software, you go, oh yeah, let me find the dry hop method. Search your whole entire code base for dry hop. It's all going to come up. Oh, by the way, if there's anything you're not understanding, on the back of that packet, I have a glossary. So like the last page, if I'm using words in brewing industry that, like dry hopping, that's adding hops in after the fermentation. So boiling is already done. Beer's almost ready to drink. You're adding the hops in right before it's consumed. So, but, maybe if you're using Beehot or Gherkin languages and things like that, you're already doing this, but you don't realize it. You're putting these in your scenarios and features. A user should be able to dry hop a recipe. User adds dry hops. Right there is where, that's your method names. You're not realizing it, things like that. But if you're not, you're just applying this, if you go in here and in Beehot, if you tell it to generate a step definition, it's actually going to generate a step definition like the user should add, dry hopping, whatever. And that's exactly what the method should be, on your objects later. And as I mentioned, this ubiquitous language, it's something that you both agree to speak. So they call it dry hop, you're gonna have a method called dry hop. Maybe they're like, oh, we just, get a bunch of ingredients, we throw them together. So you have your ingredient. Adding it to a boil. We add it to a boil kettle. It's just different ways that, the people that you're working with talk, and what they speak. Maybe where you're from, what country, maybe you want to use some of the words that are local, but understand their language, speak the same language, and apply it directly to your code. And, we're going to get into some of building business rules and things like that using, this language. So like the last one, we could have a recipe add to mash tun, and there's no reason you should be putting hops in that part. It's just the grain. We're going to build some of this logic in here to fail on things like that. So you're going to have this wouldn't be all one method, but just to kind of summarize the whole thing about naming your stuff. For the most part, a brewer should be able to understand this and figure out what is going on. Even if they're not a software developer, it pretty much reads like English. And when you're talking about them about the software, I don't know how many. Does anybody here speak a foreign language? Does anybody learn Spanish or German? So I learned German, and when I first started learning the language, you have to think about what is the German word for tree. It's Baum, like Tannenbaum. That means whatever. So you have to think about the word, what is tree. Eventually, as you get better at speaking German, you stop thinking about what is the English word for this thing. Now, it's just like in your software. If you're speaking the same language as the person that you're developing software for, you don't have to think, oh, the hops array is actually the number of hops in the recipe. I don't have to do this translation in my head. You're speaking the same language. It's going to flow easier and be much easier to understand later. So if you're comparing, what is a CRUD mud app versus DDD, kind of these objects and this naming and stuff like that. Your CRUD mud app is going to have users and strings and integers and floats and arrays of ORM objects and things like beer inventory repository interface. DDD app, you should expect to see objects called brewer, like a brewer or brewers, like a collection of brewers would be, brewers. You're going to have an object called recipe name that represents the name of the recipe. Things like IBUs, which are how bitter a beer is, alpha acids, things like that. You're going to expect to see these objects in a thing, in the software. Now, one last topic on the ubiquitous language before we start getting into actually doing an exercise is the natural identification of things in your software. Now, hopefully, if you're not using UUIDs as your database, I definitely recommend start using UUIDs for all your primary keys in all your database. It'll make your lives so much easier as you're developing software. But those UUIDs, as I'm sure you're aware, are big, long, giant strings that don't mean anything to anybody else other than us. So those are our primary keys of our database. Most of what you're developing software for probably already has natural identification built in. So if you're building software for a library and books, there's already an ISBN number on there. You don't have to use that necessarily as your database primary key, but all of your lookups and things like that should be done based on the natural identification. It's going to make understanding your software later a lot easier. Now, you're still going to have queries that are by ID, in controllers and things like that. But when you're actually building business logic and looking for things, try to use natural identifiers. So if we're looking at a bag of hops, which I brought some bags and ingredients and stuff like that for you guys to look at later, there's already some natural identifiers on here. They've already got a lot number here in the bottom of the package, so you can identify off of that. The name is a unique name. Centennial hops is a unique flavor of hops. So look at your business, and when you're finding things out of the repository for people, you can find it by name, by the string that you take in or things like that. You don't have to use UIDs everywhere in your software. All right, to sum up all of this, and this is kind of an older book, Structure of Interpretation of Computer Programs. One I was probably supposed to read in my computer engineering, one of my classes at Penn State, but I went to a state school, so I learned more about beer than I did programming probably. But the most important thing, and this is a great quote, is programs must be written for people to read and only incidentally for machines to execute. I've been at the same place that I worked for 10 years, and I looked back at the code that I wrote last week. No, I mean 7, 8 years ago, and it's just it's almost garbage. It's pretty much throwaway because it's all ORM based. It's database driven. Modifying any of that is terrifying. Like most of it doesn't have tests because that was before we started testing everything. But to try to make a change, it could take you a week to make a very, very small change because nothing is encapsulated. Everything is just scripts everywhere and doing updates and reads and deletes. And you delete one thing someplace and you don't make the updates in the other, and stuff gets haywire. Bad things happen. I'm going to try to push you guys into a place where building software that's better and it's more correct. It's going to stay correct longer and be easier to change and things like that. All right, real quick. As the business evolves, the language evolves too. So if they decide they're going to start changing the names of things, change them in your software. Move along with the business. Don't you can't just stay stuck in the 20 years ago. We don't brew like we brewed in the 1600s because people got sick all the time, stuff like that from infections. But oddly enough, beer is very, very safe to drink. You almost cannot be poisoned from beer. The only thing you have to worry about really is what is it? Whatever. It's a very minor infection. It's in none of my beer. I should have wrote it in my notes here. But anyway, the alcohol in beer kills almost everything. So it's very safe to drink. So even back in the 1600s, that's why people drank beer so much, because it was safe. The water was terrible. Beer was still safe to drink. But processes have changed. We have giant stainless steel fermenters now. They don't use barrels from the 1600s to make their beer still. There probably are places that do, but most breweries don't. So evolve with your company. Evolve, with technology. You're going to see things in the technology side of things that's going to change how the business is going to operate. It's your duty to go to the business experts or the domain experts and update the ubiquitous language there too. If you're operating a theater, you're not going to have a ticket counter forever. Now there's online ordering, things like that. You have to go to the business, and they're going to have to change too. That's ubiquitous language. It's a two-way street. It's not one way, them telling you what to do. It's both ways. All right, this is, I promise, the last thing about ubiquitous language. And when I mean ubiquitous, it's not across the entire universe. It's not, what they call a hop may not be the same thing across the entire universe. It's not even across the entire organization. It could just be that one project that you're working on with one team in the organization. So, if you have many parts of your brewery or whatever, marketing and finance and production and inventory, what they refer to as a hop may be something completely different. So for marketing, it's a flavor. So they're going to market it as something that's flavorful and things like that. For finance, it's an expenditure. It's just something we have to pay for, and it's awful. For production, that's an ingredient. They're making the beer. They're dumping it in. For the inventory people, it's just a quantity of a thing at a location. That's all they care about. So when you're building the inventory system, you're going to refer to those hops differently. You're going to have different methods, and you're going to namespace like PHP has now, which is great. You can namespace those hop things into the inventory namespace. So you're going to separate your application either through namespacing, or if you're big enough, maybe microservices. Not something I would recommend you run out and try to do as microservices. It gets very complex. But even if you have what they call the majestic monolith, the big giant application that has, like I do, we have, I don't know how many classes we have in lines. It's huge. But we still break it down. You still have to solve one little problem at a time. So when you go to talk to the inventory people, you're talking about hops. You might still be referencing databases that are similar, that are shared across, data that's shared across, but you're going to build separate code base. You're going to build stuff to their language so that it's understandable by them and understandable by you, and you're speaking the same language at the time. Because if you're like me, and I've been there for 10 years, like I said, and I built software for somebody 5 years ago, and then 5 years now we come and we look at it and try to understand it again. It's going to be a lot easier if it's written in this ubiquitous language. What I'm talking about in domain-driven design is they call it bounded contexts. So like I said, we're going to separate, we're going to silo our code into the recipe section, into the inventory section, the brew house section. Because what they call the big ball of mud, that's the CRUD app that's just got data and updates and sets and everything everywhere going on that's totally incomprehensible. Or spaghetti code or shantytown code, however you want to look at it. That's what you end up with if you don't keep things separate. The way that I recommend that you do when you're going to separate your code, obviously, the brew house is going to have to talk to the inventory system. If you do that spaghetti code, you've got stuff, flying everywhere, objects calling methods in other sections and stuff like that. If you do that and you go to update your system, it's not going to be modifiable because you want to change, say, it's been 5 years and you haven't touched the inventory system, you want to make an update. Well, if you've got all these methods that are being called in the brew house from the inventory system, now you have to touch both code bases. Keep everything siloed, keep everything separate. And the way to do that is to pass messages between the different domains. And you can do that however you feel. Like you use, if you're using Symfony, use the event publisher, build your own queue. Do whatever your implementation makes it easiest for you to do. But you're going to pass these as messages or events. You're going to publish an event and let people listen. And in DDD we call this a domain event. So we're going to pass these domain things that happen in, say, in the inventory. Ingredients received. It's going to fire up an event. And now the brew house knows, hey, the ingredients have been received. We can start brewing. So we're going to pass this message of that ingredients were received. Brew house is going to pick that up and then move on to its next thing. All right. We're just about ready to stop talking and start doing. But I wanted to stop real quick. Does anybody have any questions about the ubiquitous language and what we've been talking about? We're going to start how do you actually work with a domain expert and build this ubiquitous language through an exercise. But does anybody have any questions before we do that?
Do you have any experience in situations where you're working on a kind of multi-tenant app where different clients have different
Yeah. So what you want to do there, so if you're trying to build like a generic app that works for multiple people, is what you're saying? Like, so you have let's just say it's a purchasing app and you have 3 companies that want to use it, something like that, right? What you'll typically want to do is build your interfaces, like class interfaces, in the domain language. So what you understand is the domain, your understanding of the domain. Those will be your interfaces. So when you're applying or using those interfaces, I don't know the experience level here of classes, but you have classes which are concrete objects. You have interfaces which just define what a class can do. So you want to build those interfaces in your domain language. Then you'll probably have to build custom classes that implement things differently, but implement that interface. So that you can kind of keep things separate. And you actually namespace those implementations per the client name, if they're that specific. We have things in our company where certain rules are for only certain regions in the company. So we want to put that in there because you want to know, why the heck is this doing this? Well, it's because they asked us to do it. So we know who asked us, kind of thing. So. Yeah. Pretty much. Yeah, definitely naming and things like that. But what I'm saying is, like, if you have an app where they're typing in, let's say like in a brewery, they have a QA program where they just record values, like, oh, how much carbonation was in this, how much acid, what was the pH, things like that. You don't really have to build that domain-driven design. You can let Laravel or Symfony or Doctrine generate forms for you, generate stuff. They type it in, they hit save. There's not really any business logic there. It's just recording. So that would be an instance where it's a little bit more overhead to do DDD stuff because you're going to spend more time modeling. You're going to spend time figuring out the language and stuff like that. If it's not, it doesn't matter, just do it. I mean, it's a balance. Same thing. Yeah, I mean, I look at, like publishing versus subscribing, like kind of like what you're saying, like you're pushing to an API. That is code that you're writing, and you're responsible for testing that code when you're consuming APIs and things like that. Publishing an event out to the system, kind of like wiping your hands clean and walking away from it. So it tends to, if you have very separate systems, it tends to work better for things that are happening that other systems need to respond to. Now again, like you're saying, you may have an API to the inventory system or a service that can, if the brew house needs information from the inventory system, yeah, build what they call, so I'll get into this hopefully later, hexagonal architecture. And it talks about what they call ports and adapters. And really what you want to do is you're going to have a very simple interface that's between the inventory system and the brew house. So your method's very clear. It's kind of an API, or again, if it's a microservice, you're going to separate that into a completely different web server. But you want to have these very tiny classes that transfer those messages across, just like publishing an event. So you can still talk to other domains, but it's done through a very restricted channel. So that when one changes and the other one needs to be updated, you don't have to update both sets of code base. You just have to update the adapter. Okay.
Have you ever had an experience where programming has so many
No, I haven't, because I would usually defer to the business, because it's their problem you're solving. I mean, it's, you can convince them otherwise. All right. Any other questions? I'm going to pass out some treats. There's a tradition in the brewing industry for these nut rolls. So you guys that ask questions, is anybody allergic to peanuts? That I just asked a question. Yeah, no. Too late. No, I'll have extras at the end. All right, so we got a few minutes before the break here. What we're going to build the ubiquitous language through is an exercise. It's called event storming, and this was done by created by Alberto Brandolini. But when you're building this ubiquitous language and this thing, you want to go out and actually meet with the domain experts. Having somebody pass you the specs is not the way to build software. A million tickets in Jira and have a burn down chart is not the way to build proper software. This is me out on one of our ships, meeting with the crews and stuff, learning how to build software. UX professionals, they call this ethnographic research. It's a fancy word for saying get yourself out from behind your fancy desk that goes up and down and get out there and learn. On a brewery, that's actually probably pretty fun, but on a ship, it's just smelly and dangerous. So, and it makes you seasick. You'll hear this thing about user experience, talking about personas. Don't worry about personas. You shouldn't be thinking about personas. I love this example of personas. It's like, oh, we're going to build software for a brewer, and he loves poetry, or she has a library science degree and just got a job at the brewery. No, you know what? Actually, these are all the same people. They're just all in different makeup and disguises. That persona doesn't matter quite as much. It's kind of something that's been created by UX professionals so that developers don't have to talk to the clients, I think. A lot of times, like, you build these personas, you end up building either a racist or a stereotypical piece of software. I love this example here, but it's a computer, but why does it have to be pink? Because it's for a girl. It doesn't make any sense. Or you're building software for women. It doesn't need to be pink. I read a great quote. It's like, please remove age, gender, ethnicity, locations from personas. None of that makes any difference. As these guys that have nut rolls, no. It didn't matter where you came from, what your age is, what your experience is. You're hungry and you wanted a nut roll. That's why you wanted to ask that question. Solve the problem that you have. I mean, there's a great book that's user experience that's talking about user research. And you go read that about getting in the mental model of the person. When you're meeting with a stakeholder and building a ubiquitous language, we talked about the 5 whys. Understanding the business problem. When we do this exercise, I don't want anybody to be using what I call the 7 dirty words of meeting with a domain expert. And it's just like George Carlin words, but these are worse. Session, repository, abstract, interface, class, database, foreign key. Those are really words that nobody else understands except for all of us. Don't use those words. All right. So what you're going to do is you're going to get your sticky pads out and your pens and markers. And we're not going to build any kind of user interfaces yet. We're just going to try to understand the problem. And the reason you use sticky pads, markers, and pens is that not everybody else is as good as using computers as we are. You know, they're maybe not as technically inclined. You know, I had a meeting one time, I was scrolling through software so fast, the guy said, hey, you're making my eyes roll back in my head. I can't read, you know, as fast as you can. So we're gonna get low tech here. We're gonna use sticky pads and pens, markers, and stuff like that. And we're gonna build a model of the problem that we're trying to solve. And you have colored things in your little stickies there. We're just gonna create like basically a legend of what things are. We have a domain event, which I'm gonna explain, a command, a model, and an actor in your software. A domain event is something that happens in the software. It's past tense. Like beer was brewed, grain was added, hops were added, brewer changed email address. Things like that, things that happened, you know, will have happened in the past once the software is working. And you just start building a chain of these events as you go through. So recipe was created. The grain bill was added to the software. You start building a huge chain of events. Eventually the chain gets so long, you realize, oh, we're talking about recipes and brewing. That's where you can start identifying your bounded context when things get too far, too big and complex. So, you know, we split it down. We just look at, maybe we'll just look at the recipe context here. So these are the things you're starting to get about building a recipe. You're going to be adding grain, adding yeast, adding hops. You know, as you go through I'm just going to speed through this here, but you know, you look through the different events that happen in the system. So I'm done talking, promise, for a while. Why this is not going forward? Yeah. All right. Promise. Done talking. You don't have to listen to it anymore. We're gonna take a little quick break. Let's try to keep it like 5 minutes or so. Get your coffee, use the bathroom, whatever. Come back, and we're gonna start working on this event storming. When you go back to your companies and do this, I'm gonna do the same thing. Recommend that as you start the session, you put up the first orange cards, which are the events that have happened in the system. You write the first ones, get the ball rolling. You may not be right, that's fine, but at least if everybody's just sitting there staring at each other, they're not going to know what to do. So I've created the first 4 things in your, if you're looking at this diagram that I gave you earlier, these are the first 4 things that happens. The brewery plans a session. They make a yeast starter, which you don't have to worry about too much. They measure the grain, and then the grain they mill. That's the first, one of the first things there is the grain is milled here, and then it's put in the mash tun. So those are the events that we're going to talk about. And you guys are going to come, when you get back, we'll start working on that. So as soon as you get back, just start working. I'll be around to answer questions. The reason we're writing these in the past tense and present tense is that's how they're going to translate to the code. Other than that, there's not really a really good reason. So examples of codes, if you're looking at the brewing stuff, it's like a brew session was started. Start a brew session. Add grain to recipe. Add hops to fermenter. Those are the things you're going to be adding now. So recipe was created. Your command is going to be called create recipe. The grain bill was added. The command is going to be called add grain. Water profile is selected. However you guys have kind of come up with this. You guys are your own domain experts, so however you did it is correct. So go ahead, take the blue stickies, translate your event into a command. It'll take you just a couple minutes. You can keep adding your commands if you need to, but moving on, the next thing is the models. So now is when you can kick in your developer brain a little bit and start thinking about the objects and stuff that you're going to be relating to. So this is the things that the commands are done upon. And that might be both, in your case, the model that you're looking at, like the recipe or the ingredient or the brewer. It might be related stuff. So if you're doing the recipe context, create recipe, that deals with the recipe. Adding grain, that might be the recipe and the grain. Kind of, you're just trying to figure out what's all involved. So take a couple minutes and work that out. You don't need to write grain 17 times if you can remember, It's not necessarily the data, it is the things that you're acting upon. So, you're interfacing with a brew kettle, that could be on there. Your objects, it's the things in the world that your software is trying to model. Don't worry about, okay, we need to know for grain, we need to know its name and its weight and its things like that. Don't worry about that kind of stuff. Okay, so I think you guys you're far enough along on that one. The last thing, and we're kind of actually done because the last one is the actor, and that is who did the command, who did the action. In this case, we probably have like one person, the brewmaster or the brewer. So it's probably going to have the same person on every task. So I'm not going to make you put a green sticky on each one. But I do have to congratulate you guys. You guys' diagrams are pretty good. They're terrible. No, I'm just kidding. So that covers kind of building the ubiquitous language. Does anybody have any questions about the process? The only thing I would say that I've noticed, you guys did a good job of naming all your stuff. Some of the things you're going to have problems with in code. So if you called something grain, and then you had an object that's called milled grain. Now that's fine when you're building this, but you're going to have a problem. You're going to have problems transitioning objects with PHP. It's difficult unless you separate them into different bounded contexts. When you have an object called grain, and you have a function called mill, you can't change that type of object. So it can't translate into a new kind of object. You have to create another object called milled grain. It gets a little complex. So sometimes you may want to store the state of the grain as a property of that object, not having a new object called milled grain. But it might be important enough that maybe they're dealing in one section with just milled grain. So you may have an object called milled grain. It's possible. Does anybody have any questions about this? Yeah. Sure. So it's basically the who did it. So later when we look at the command, it's going to be the person who punched the button on the software that said add grain. The grain was added. It's going to be tied to the event. They're going to be a model in your somewhere in your software. You're going to have an object called brewer. That's going to be the person logging into your software and using it. So they're not exactly a bounded context. They're not really part of any of one particular bounded context. They're what's called a supporting bounded context. So they're going to show up everywhere in your software. There's not really a way to avoid that, other than you can, if it's complex enough, you may want to create a inventory user interface or something like that. So that way you have a limited set of functions on the user in that area of the software. That might help keep things a little bit better organized. Or if you have very distinct teams that are working on different parts of the software, you're more likely to do that, where you have your user, which is like a Symfony user, a Laravel user, and that might end up implementing like 15 different interfaces from different namespaces. Does that answer your question? Good. Yeah. Yeah. Event storming. Event storming. Yeah. There's other ways you can do it, and I'll kind of touch on those real quick. You guys started building diagrams. You can see they're already getting kind of large. You're going to want to break those down into bounded context, like I mentioned, as the thing gets larger. You start circling them off. If you're doing it, do this on a whiteboard or a big, giant, long sheet of paper, so you can start doing it over and separate the stuff out. These, like I mentioned, these events are going to be pushed around to the different contexts. So, like the inventory context needs to know when a brew session is planned to make sure the ingredients are there, something like that. We're going to order the grain for them automatically or something like that. And it might be, multiple events from the same bounded context that are coming to it. If you're really having problems understanding the process, the business process and stuff like that, there's a couple other techniques you can use from user experience side of things. One's called business origami, and I learned about this at 2011, in 2011 at UX Week. There's a handsome guy in the background there. But basically, you make these fancy little cards, and you actually physically, let me jump ahead a little bit here, you'll see. But like if you're building like an e-commerce thing, you actually physically move the people around the origami store, so to speak, buying things, so that way you can identify which cards to write on the process. So it might be useful to actually build a physical model of the real world, in paper or something like that, in order to figure out, what cards, do we have in our event storming session. There's other ways to do this too, like they call it user story mapping. And it's kind of the same thing. You build like a big long list of events, and then you try to find the different things that you're going to do and break it up into planned releases and stuff like that. But I think the idea here is that we're going to identify the behavior first. People think about software, they don't think about database models, like I was mentioning. They think about what does the software need to do for me. So they're thinking that, I need to be able to add grain to this. I need to be able to, do things. Those are the events. So starting with the events and starting with the things that have to happen in the software is a much better way to build software other than starting with the databases and the data. So I would give this, a correctness and usability much higher as compared to, CRUD code. All right, so we're going to start talking about actual code. And how do you implement this ubiquitous language, and how do you, make software that is maybe completely different from how you guys are writing it today? And what I mentioned earlier is going to be heavy on the object-oriented side of things, but it's hopefully not too difficult to understand. In domain-driven design, we have pretty much 4 basic kinds of entities and objects in our system. We have value objects, which are going to represent small things in our system, pieces of information. Domain events, those are the orange cards that you put in your event storming session there. Those are going to translate exactly to objects in your system. Entities, those are your yellow ones. Those are the models. You have a grain model that's going to become an entity. Aggregates, those are your fancy models, and I'll get into that. They basically contain child entities. So, a value object, like I mentioned, is the smallest pieces of your software. Biggest thing about them is they're going to be immutable. They have no identity. I'll get into that. But examples of value objects in the brewing thing is like a hop name, an amount paid, a temperature, things like that. They're values. They're not things that have things that are changeable about them. Entities are things that are identifiable, and they're mutable, and they have a life cycle. And they're going to operate on those smaller value objects, and I'll get into that later. But an example of models might be a line item in an invoice. You could change the quantity or change the price. That could change over time, or you could delete the line item. So that has a life cycle. Brewers, their names change. They come and they go. They're fired. They're hired. Water chemistry. You might have a model for your water chemistry. Well, your city water changes daily. So if you're measuring it, you're going to be constantly updating your water supply. An aggregate. So an aggregate is basically a fancy entity, a bigger entity, and it is responsible for managing smaller entities. And that's its primary job. It's going to have business logic for sure, but it's going to be the larger, more identifiable objects in your thing. So if you had things in your event storming session like brew session, that's going to be controlling some things as far as what state we are in the process and stuff like that. The recipe is going to, if you flip to the recipe that I gave you in the packet there, it has hops, it has grains, it has yeast. It's got to contain all these other models. So it's got to manage, and it's got to hold them all together to build one giant thing called a recipe. That's an aggregate. But if of all of those things, value objects are by far the most important. So the value objects, again, we were talking about out of the brewing thing. You might have an email address for a brewer. I don't know. It's kind of an easy example. A recipe name, the date we brewed the beer on. That's an example of a value in the system that is immutable. You can't change when we brewed it on. The weight of grain, you might have, that's 13 pounds is 13 pounds. You can change, how much grain you've weighed from 13 to 15 pounds, but the value of 13 pounds does not change. That is 13 pounds. 70 degrees Fahrenheit is 70 degrees Fahrenheit. There's no changing that. If you change to 71 degrees, that's a new temperature. And all these value objects in the system are going to come directly from the ubiquitous language. That, when somebody, if they call it, the date we brewed on, you might want to shorten that to brewed on in your code or something like that. But if they call it a recipe name, it's a recipe name in your code. And we're going to have classes that map directly to the classes, or we're going to have classes that map that ubiquitous language directly to the objects in our software. So if you're talking about temperature, in the brewery that you're building software for, it does everything in Fahrenheit. Well, you're going to have a class called degrees Fahrenheit that's going to represent that. There's no reason to build it out in Kelvin. Brewers don't talk in Kelvin. They don't think about in Kelvin or even maybe degrees Celsius, depending where they're from. So have a degrees Fahrenheit class, because that's how they're going to class in your software, because that's how they're going to have to put information in. They're going to want to use degrees Fahrenheit and everything. They're not going to have to convert. And these objects are not just about creating classes that do static typing, meaning type hitting in your functions. That's not the point of them. There's studies that have shown that just the variable names is enough to keep you from swapping parameters. That's not the whole point. The point of value objects is to reduce complexity and reduce checking in your software. So value objects I mentioned are immutable, meaning they do not change. There's no factor of time involved in a value object. The temperature doesn't change over time. 7 degrees Fahrenheit is 7 degrees Fahrenheit, regardless of when it is. The other reason you want to have as many objects in your system immutable in your software is because PHP passes objects by reference. And if you pass an object to a function that is mutable, so that function could change something on that object, and you don't know that. So when that object that you pass in could be changed. Now, if it's an immutable object, like a value object, and you pass that to the function, you don't have to worry about that object being changed. So if I pass 70 degrees Fahrenheit to a function, I don't have to worry about it coming back as 68 degrees. It's not possible. That object is locked and it's immutable. There's no possible way to do it. The other thing that helps you in your software here is your value objects will always be in a valid state. Now, they don't have state, but what I mean by that is they're always valid. So 7 degrees Fahrenheit is a valid temperature. Now, if anybody remembers from high school physics, there's something called absolute zero. You can't be below 273 degrees Celsius. 300 degrees negative Celsius is not a valid temperature. So we're going to prevent that in this value object class. So anywhere you deal in temperatures, it's always a valid temperature. Value objects become like the thin candy shell in your application, where everything stops and keeps everything from hitting the nice creamy center in the middle of your application. The earlier you can solve problems in value objects, the easier you're going to have time building software. If you're not doing you're not doing test-driven development now, value objects are a gateway drug to test-driven development. They are by far the easiest to develop doing test-driven methods. Hashtag my tests don't pass. So what are value objects? They're, like I mentioned, they're just small little classes that have one purpose. They're plain PHP objects. They don't necessarily have to inherit from anything or be part of something else. They're call them popos. I mean, a plain old PHP object. All their properties are private. There's no public way to change anything about them. There's no setters on them. Like I said, you can't change anything about them. They're mutable. They don't hold references to mutable objects. So like a grain, for example, you can't have that as a value object because the grain could actually change. Like different acids and stuff like that, or enzymes could be different in the grain. So you can't hold a value object and have an entity inside of it that can change. It's not possible. That value object, if it's 70 degrees Fahrenheit, like I said, it should be 70 degrees Fahrenheit forever. There's no change to it. The biggest difference in domain-driven design code versus most code is we're going to throw as many exceptions as possible in the construction of these objects. And exceptions are going to be your friend. You're going to catch these exceptions when you need to react to it. But for the most part, a lot of your validation is going to come from throwing exceptions in the constructor. And like I said, value objects only depend on scalars and other value objects. So like I said, you can't pass an entity to a value object and hold it. 70 degrees Fahrenheit, to hold that, you need maybe a float that's 70 and a unit that's Fahrenheit. So it might be two values you need to hold. Those don't change. That's all the dependencies that this value object is going to have. And they're not dependencies that you have to inject either. So sure, if you're following solid principles, dependency injection, things like that, if you have repositories and services and stuff like that, you don't want to just be littering those willy-nilly in your code. That's a bad practice. Value objects are a little bit different. They're pretty much like scalar types. Like, do you worry about having integers in your code anywhere? Or strings? No, you don't. You don't worry about that. These are pretty much just an extension of the scalar types. So don't worry about saying new temperature anywhere in your code. It doesn't have any dependencies. It's designed that way. It's going to be perfectly fine to have those new things happening in your code. You may, if a value object gets very complex, you may need a factory, which, if you guys are familiar with patterns, you may need a factory to build that value object. Sure, you might want to inject that in that case. But for the most part, value objects, you just put them wherever you need to put them and use them. All right. Enough talking about value objects. Let's look at an example. And I put this example in the packet that I put out just so you guys can see it a little bit closer. But let's talk about the business rules. We're going to apply those directly to our code. So the brewers have told us that, yeah, we name all our recipes. They have to be nice, creative, witty names that we put up on the board and everybody smirks at, and they sniff it first and drink it. No, I mean, so important thing is to have, some business rules associated with this recipe name. And basically the business rule is that a recipe name cannot be empty. So if I create a new recipe name object and I pass an empty value in, it should blow up. So it's going to throw an exception. If I pass in a valid name, it should give it back to me in the getter. So it's get value. It's kind of a simple way of saying, give me back the value of this object. A lot of times I like to do on these simple value objects, if you can cast into strings, we'll put a toString method in that'll just cast it. So you don't have to have get value everywhere in your code. It can get a little verbose. Hopefully those are nice, witty names like IPHPA and recursive Weizen. So like I mentioned, the recipe test, I think you guys can see that I printed it out. So like I said, we're doing test-driven development. We've added our test. Let's run it. And everything fails because the class doesn't exist, the method's not found, all of that. So let's start by building that class. And like I mentioned, the thing that we're going to do most of the time in these value objects is throw an exception in the constructor when things fail. So when you're building your value objects, you're going to try to identify the failure points for these value objects. So if the value that's passed in is a string, we don't have to test if it's string because we're using PHP 7.1. If we were using PHP 5, you couldn't type hint that string there if it was value. So you'd have an additional check, like if not is string in PHP. You would then throw an exception saying this is not a valid string. But yeah, I mean, if it's empty, we throw an invalid recipe name exception. In this case, I've created an exception class because maybe you need to deal with that exception specially. If you don't need to deal with the exception specially, in this case, throw an invalid argument exception, which is in the root, base namespace of PHP. That's perfectly fine. I do that in some of the examples. And then we hold the value. And that is enough to pass our first test in that recipe test thing, where it's testing to make sure, hey, we pass an empty string, it fails. Next thing we have to do is we just add a get value function, and that returns the value back out of the value object. Again, run the next test, test passes. And then the toString, that's really easy to implement. You just get the value back. You could also just wrap the get value function. Internally, you could just call that public function internally, not a big deal. I mean, again, I wouldn't stress too much about the value objects and how you implement them. As long as you're testing them and you're wrapping things in tests and you're identifying the fault points, internal code, if you want to, get fancy with your implementation there, that's fine. Do whatever you want. Important thing is you test. Lights are green. Tests are clean. It's in the trap. The thing is, it's locked down. So now, as we look at this recipe name class, anywhere I use this in the system, I'm guaranteed that the recipe name is valid. So it's kind of a different way of looking at code, is you no longer ever have to check on this recipe name. Throughout everywhere in your code, recipe name is now valid. It's now a valid object. It's not possible for somebody to create an invalid recipe name. Look at another example, get a little bit more advanced. So brewed on, like when was the recipe brewed on? We write a test for that. We're just going to create a new date time, and it should give us back, a date time immutable value. So you just hold it. Date time already does the validation for you. It's going to throw an exception if it's an invalid date. So for the most part, you're done. But if you want to add some business rules in there, maybe to catch edge cases and things like that, you can. It's not possible because we're writing this software today for there to be a date that's less than 2017 November 15th. It's not possible. The software didn't exist. So throw an exception if the date's too far in the past, or maybe we know this software is only going to last a year, so we put it in the future. Things like that. You want to try to stop anything you identify that are problems with that object in the constructor. Another example of pounds. We can test that value, like I mentioned, make sure it's a float. It's not really possible to have a negative weight, unless we discover antimatter. Weight is always positive, so you can treat pounds as positive in your system, and throw, like at the bottom one here, test negative throws exception. It's easy to check that value is less than 0. It may not be negative. Now, because PHP can be screwy sometimes, you want to identify, like I said, pounds always must be positive. You want to identify a way that makes sense to both you and the business of what this object is going to represent. PHP has this nasty thing of a -0. what is negative 0? It doesn't make any sense. Let's eliminate that from our domain. So we can just cast it to a regular 0 if we have negative. That way, if they print it out and it's 0 pounds, it doesn't accidentally show up as negative 0 pounds and confuse the hell out of them. Your toString in this case, maybe the breweries decided that they don't have to worry about anything less than 0.001 pounds. Do your formatting in your value objects. Do your rounding. You might want to hold the entire value if it's like a long float. You may want to hold that. But when you get the value out or we display it to them, you handle your formatting here. Now, that's only for simple things, like pounds and stuff like that. If you have dates and more complex objects and you need to format it, again, looking at solid principles, it's a good idea to separate your formatters into another class or into a template, things like that. Again, those policies apply. The thing I mentioned about immutable in the value objects doesn't mean that you can't have behavioral functions on in a value object. That is definitely possible. The trick is, though, we're going to return a new object if you change something. So if we had 10 pounds, and we want to reduce that amount by 6.1 pounds, we expect a value of 3.9. Now, what that is actually going to return is a new pounds object with 3.9 pounds in it. As I mentioned, that original one 10 we passed, it's not mutable. So it cannot change. It will return a new object. So like I mentioned, the biggest thing about value objects is it eliminates checking. So the pounds object decrease by function, a little bit hard to see maybe there at the bottom. But yeah, like I said, the first thing you're going to do there is new self in your object. So you're going to return a pounds object. Because like I said, the value objects are immutable. You cannot change them. And you're just going to say this value minus decrease by pounds get value. You don't have to check and see if that pounds are negative, or like in the case of the recipe name, you don't have to check if it's a string or anything like that. It's all done. I don't even have to check that when I'm subtracting, say I have 6 pounds and I try to subtract 10. I don't have to check that here because it's not possible. The constructor will catch that because this will come in as a negative value and it'll be -3 and the exception will be thrown. Weight cannot be negative. So a lot of your checking and if logics and stuff like that can be handled by the value objects. Like you mentioned the 70 degrees. If you try to subtract 400 degrees from that, it's not possible. The absolute 0 is going to catch that. Do you have a question?
I was wondering about different.
Yeah.
There be a rule against having like a value object, like a value versus pound, kilogram.
Yeah, that's perfectly fine. Like, yeah, if you had a weight object and say you just want to deal, because you're dealing in many measurements. Like let's say that not like a brewery where it's all pounds because it's in the U.S. Yeah, you have a weight object. You're going to have to store, I'm going to get into this in a second, but they call it a composite value object. So weight is going to contain 2 distinct value objects probably. Maybe in the case, probably just a float, just a regular PHP object float for and then a string or a unit of measure object that represents the unit. So then anytime like this, if you're like decrease, like let's say it's kilograms, you try to decrease it by pounds, and you can throw exceptions there and say like, hey, you know what, the units don't match, or you can do the conversion if that's business is like, yeah, we get stuff randomly all the time, we want to do the conversion automatically. Be nice and do it for them. Don't throw an exception and say, oh, you must put this in pounds. Build these rules into your business. Build intelligence into your software. Like I mentioned before, the factories. If it's difficult to create an object from a string or something like it, feel free to build a factory if that's the way you want to do it. I mean, it's fine. However you operate, building your code now is probably for the most part fine. It's mostly just naming and understanding that these value objects are going to be immutable and always valid. One of the things I like to do on stuff is like static constructors on these value objects. Go ahead real quick. Yeah. Now PHP, especially 5 or 5.4 up, objects are incredibly easy to generate. The only time you'll run into a problem is if you build recursive like issues where, okay, I want to make sure that the Fahrenheit object can't be below absolute 0. Well, I can't build a absolute 0 Fahrenheit object that extends Fahrenheit because it's not possible for it to be absolute 0. It's just not, so you end up having to make sure you kind of separate things a little bit. But Objects are cheap. PHP objects are very, very cheap. So don't be afraid of creating all these objects and stuff. Good? Question? Okay. So static constructors, and I like to call these natural language constructors. They're coming from the ubiquitous language. They're coming from what somebody talks about. Maybe in the example here we have pounds, but sometimes we get stuff in that's metric in kilograms. You have a function that's static function from kilograms. And this will return a new pounds object and do the math for you. Now your software is just dealing in pounds. It's not worrying about kilograms and stuff like that. But we know that that weight is always valid. So, yeah, I mean, you may even want something like from string. So if somebody writes like 2.0 LBS, you may want to write some parsing logic there that does some regex or something fancy and does that. I think I've done the temperature example here a few times. You get the formulas and stuff like that. I was going to do an example, but I think I'm going to move past that. Does everybody kind of get the idea that we're you're creating these objects, they're immutable, and you do all the validation in the constructor? Just think everybody got that? No. Yeah, do whatever you need to do. Like I was saying, like it's 2 afloat, pounds a string, something like that you need to measure. And I'm just about to go into like composites of these. So, but like I was saying, the units are important. Getting those right. If you've heard stories about the Mars Climate Orbiter that crashed into Mars because they were working in miles and kilograms, things like that. There was the plane called the Gimli glider that they weighed the fuel in kilograms instead of pounds. It didn't have enough, had half, whatever it was, less than half the fuel it was supposed to. Had to, crash land. Luckily, nobody was hurt. These are the kind of things you can eliminate by using these value objects and making sure that it's not possible to have invalid state in your app. All right, so composite value objects. Easy example would be a brewer's name. So a brewer full name, might consist of a first name and a last name. If we look at the full name object, there's really nothing to validate here other than the fact that there is a first name and a last name. Because first name is a value object. It's just going to make sure it's not empty, just like the recipe name. Last name, value object. It's going to make sure it's not empty. So the full name, we know now, passing that around anywhere in our system, we know exactly what a full name is always valid. It's not possible to have empty strings. And right here, we can implement the toString method of how to represent that in the system. So if later you decide to add middle names and suffixes, prefix and stuff like that, you don't have to worry about where you've said toString or get value on a full name or formatted that. It's you just have to update the constructor and where you've used it and stuff like that. But yeah, I mean we've eliminated a lot of checking here. There's no checking to make sure first name is not empty and last name is not empty. We're relying on these value objects to compose themselves. We're gonna the goal here is to encapsulate as much of our business logic in the value objects as possible. Like I mentioned the temperature thing. You can get very complex with these value objects. So one of the things that a brewery is very concerned with is the amount of alcohol that is in a beer. They have to put it up on their board. They have to tell you by law how much alcohol is in a beer. And they call that ABV. If you see that up on the board, that'll tell you, alcohol by volume. It's 7% alcohol. That's kind of a stronger beer, so don't drink 10 of them. But the way you find out how much alcohol is in a beer, you can obviously send it out to a lab and spend a ton of money, have it analyzed. Or you can just calculate it using some measurements. And if you know about the brewing process there, like I was telling you, if sugar and yeast turn alcohol and CO2 out the other side. There's actually a chemical equation for this, but I'm not going to bore you to death with that. But if we're trying to calculate the amount of alcohol that comes out, we don't care about the CO2, and we don't care about the yeast. That doesn't affect the amount of alcohol that comes out at all. Well, we care about the sugar. And the amount of sugar we start with, and the amount of sugar that we end with. Now, like I said, yeast consumes sugar. So if we know how much sugar the yeast consumed, we know roughly how much alcohol a yeast produces when it eats that sugar, we can calculate how much alcohol is in the solution. So we get alcohol by volume by dividing those two things, subtract from each other. Now you measure that amount of sugar in a thing called specific gravity, but it's basically the density of the sample versus the density of water. And you can do that very expensively. If you're a professional brewer, you probably buy a machine to do that. But many craft breweries and every home brewer does, and I have one of these up there here if you want to look at it later. It's a hydrometer, and basically you put it in the water, or you put it in the wort that came out of the boil kettle, and you measure how far it floats. And so it floats in the solution. It has a little scale on it, so you can measure how much it goes up and down. And if you know anything about chemistry, the density of something lowers as it heats up. Things expand. Like water actually grows, I think it's like 5% from cold to boiling. Like the volume of water grows in a solution. So when you're measuring that specific gravity, you have to know exactly what temperature you're measuring that specific gravity at. Because, like I showed you earlier, that hydrometer has been scaled and measured at exactly a certain temperature. So in my case here, I have a 60-degree hydrometer. So that scale is meant for 60-degree Fahrenheit. And you can look it up on a table and figure out how much to move the temperature with specific gravity. Or you can calculate it very easily. So I look at, I put a thermometer in when I do the measurement. So I know, like in this case, it's kind of hard to see there, but 66 degrees, and I measured the specific gravity, and my hydrometer's set at 60. Do a little bit of math, and it's actually kind of complex math, but you can calculate, what it was supposed to be reading. So if it read 1.040, we know it's actually 1.041 because the temperature adjusted it slightly. And it's not a very hard calculation to do, so kind of use this as an example with the composite value objects to do this. So the hydrometer test, we're going to look at the building a test for this first, because like I mentioned, testing value objects is pretty easy. And I just pulled values from that table, and when the temperature is exactly the temperature of the hydrometer, everything should match up. That's an easy test, right? Then we do maybe a test a bit higher, put some values in there, do a test a bit lower, do the same thing. And we're going to end up building a composite value object that's called a gravity, or original gravity in this case. If you're measuring it before the yeast has eaten the sugar out of the wort, it's called the original gravity. So we're going to create a value object that's called original gravity. And to read the gravity reading, like I mentioned, you read the gravity reading off the hydrometer. So that's a float value object that we've made sure is within a reasonable range. And a temperature that we know is within a reasonable range as well. So we know that we can verify that the hydrometer class here value object can tell you, you can't read a value above or below the scale. And we can do the logic right here to correct the gravity for the temperature. So it's, like I said, a big long equation, but it's all centralized in this value object. So the business rules and the business, the way they do things, we're putting as much as we can in the value objects. So like I said, we want to find the gravity here, the alcohol by volume. This is the formula right here. There's our readings. Original gravity is OG, and final gravity would be after the yeast eats it, and that's the formula for creating it. Now, we can also create a composite value object out of that. We can have a gravity range. So gravity range value object becomes a original gravity and a final gravity. Now, we can make sure right in this value object that the original gravity is lower than the final gravity, because as the yeast eats sugar, the amount of sugar in there becomes less. The gravity actually becomes lower. So we can verify that somebody's putting in stuff properly, and that's all this object needs to be. It just needs to be a holder of those values, perhaps. And then the class, when we write the alcohol by weight and then the alcohol by volume, can work from that gravity range. So this is again another value object that has a static constructor that creates itself from another value object, and the formula is right in here. So I don't have to validate anything, as far as the gravity ranges go. All that's been validated for me, the temperatures, the readings, all that stuff's validated. I just have to worry about building the formula here and doing the math. And to actually calculate ABV then, we do that final function equation there, and we end up with another value object that is the alcohol by volume. So you can guarantee everywhere in the software that the alcohol by volume has been validated, nothing to do, no checking. I want to contrast that, real quick with, I mentioned that brewer wall, and that's a PHP software application. But if you look, and this is just one class of calculations they have, they have ABV, OG, and final gravity. They're checking, is the original gravity more than the final gravity? Is it a numeric value? Is it a numeric value? They're doing that. And if you look through that one class, as they do it over and over again. They actually, you can't see because it's getting cut off the top of the projector here. But they check OG greater than final gravity 5 times in one class. So right there, you're repeating code. That's one of the first things we learn is don't repeat yourself, don't repeat yourself, don't repeat yourself, don't repeat yourself, don't repeat yourself. That's a big thing in code. The is numeric checks, not having those value objects that represent a float, knowing that a final gravity is accurate. They did that 39 times in one class. Passing these value objects around, eliminates a huge amount of checking in your software. You've put all of that checking into small little classes that are very, very, very easy to test. Now, like we mentioned earlier, not doing things in DDD, some things are CRUD. Even things that are CRUD, I still use value objects a lot because it makes that stuff a lot easier. So like I mentioned, DDD, we have these objects, recipe name, temperature, date brewed. Those are all valid. We know they're valid. CRUD, like I said, strings, floats, you don't know what they are. Functions, validations. Testability, usability, I think is a lot higher. You don't have to worry. The users don't have to worry about accidentally screwing formulas up, things like that. Another check there. And of course, we all test our code, so all the time. No, but it's obvious that you're not going to have time to test everything. But value objects, I would say, absolutely test them. And because those are like I said, the very first thing that your application, put as much logic as you can into them and focus on them. Because when you're building entities, and these are the models I was talking about, you're going to rely heavily on those value objects. So those entities, like I said, they're identifiable, they have state, they're mutable, but they operate on the value objects. They use those value objects in order to store values and change over time. Ideally, they're storage agnostic. Now, that's not always possible, depending on what frameworks you're using, stuff like that. Laravel. Sorry, you may not be able to do that quite as easily, but if you're using Doctrine and stuff like that, it makes it a little bit easier to just keep your stuff storage agnostic and then do mapping later. But do as much as you can in the value objects. Put as little as possible in the entities. Your entities should just be storing values and holding state. Use those doctrine mappings, doctrine annotations. If you're Laravel developers, I'm sure there's a few of you in the crowd. Nothing wrong with that. You'll do this a little bit differently. I'm going to show examples in Doctrine. But Laravel, you probably will use your ORM objects to hold state. So you're going to pass those to your entities and hold state. That way your entities can kind of worry about business logic that's associated with it. So you're going to map in and out of value objects in order to do your mapping through the ORM. Behavior first, storage second. So like I made you guys do the event storming, thought about modeling. We weren't worried about data and stuff like that. Entities, again, I mentioned earlier, single entity, aggregates contain other entities. Just to kind of keep those two in your head. The code behind them is almost identical. It's just that the aggregates store multiple entities. And if you're doing transactional stuff, your transaction boundaries are going to be around the greater aggregates. So when you save a recipe, you want to save all the hops and grains associated with it all at the same time. If you have a recipe and a brew session together, and you're operating those in the same controller because you've done too much in one place, that happens, has to happen sometimes. Persist the recipe, then persist the brew session. You could do that as all one big transaction, but put each one in its own transaction as well, if possible. It'll just make your life easier because you're already dealing with enough. Like I mentioned, how you make an entity. It has an ID. Again, recommend using UIDs. Has functions like change name, change email. It's going to be mutations on that. So we're going to try to avoid setters. Now, these are kind of like setters, but I'll kind of get into some more behavior that we're going to have. If you look at the constructor of a brewer, what is required for a brewer? You need a username, a full name, an email address, and a password, maybe to store a login or something like that. We don't have to validate any of this. This is basically our, our entity. We've validated it. There's nothing to do here. We know the full name is valid. We know the username is valid. Your entities become quite simple. They're just storage of stuff. And like I mentioned, setters are bad in entities. We want to avoid what they call anemic modeling. If you look at an ORM, like I've written one in the past, it's terrible. But Propel is a good example because more people know it. So you say new book, and then you set title, set price, new author, set. At no point, do you know exactly when the book is in a valid state? If you don't have, is price required? Like you don't know, like until you go to persistent database, is this book in a valid state? Your entities should always be in a valid state if possible. Now there's going to be some times where you can't do that necessarily, and you need to try to contain that as much as possible. But you know, in the case of a book, if it requires a title and a price, put those in the constructor of that object, and have them be value objects, so you know that it's a valid title, a valid price. There's no reason to like have this be in limbo anywhere throughout your app. If you're calling two setters in a row on an object, you're probably missing a domain concept. So if you know, the mash thing that we're talking about, if it's like set temperature and set quantity, set this, set that, you're probably missing some concepts there in your domain that you need to look at. But basically, calling any two methods in a row on the same object, you might be missing something there. It's just kind of, it's certainly possible you might do that, but something to keep in mind. Passing more than one parameter, you know, passing multiple value objects. If you passed around final gravity and original gravity all the time, you know, maybe you should think about creating that gravity range object that holds the two together, so you only have one object to pass around. Just simplifies your code a little bit. Look at another entity. We're going to look at this. You know, you have grain. It has a name. It has a type. Maybe it's, you know, wheat or something like that. Lovabond, that's the color of grain, like how dark of a color it is in the brewing language. Degrees Lintner, that's how great is it at converting from grain to sugar. You know, those are things that brewers care about. We're going to put those into value objects, so we're going to store those in the grain. I mentioned behavior is the most important thing, but I know the developer reptile brains are spinning. How do we deal with storage and all this stuff? If you're doing doctrine, I recommend doing the doctrine annotations or doing the YAML. It doesn't matter. But you know, you're going to end up storing these back to tables in your database. They're just entities, just like you do usual ORM objects. The only thing with doctrine is, you know, doctrine doesn't know how to store these value objects necessarily. And you can write embeddables in doctrine and do all that, but it's kind of a pain in the ass. So I recommend, you know, just cast those back to strings and integers, your value objects. You know, you should have a get value off of that can give you the primitive that you can store in your database easily. And then your getters that you pull off of that, well, when you call get name, put it back into the value object so that all of your getters on the entities that you need return value objects. All of the methods on an entity should either return a value object or another entity if it needs to. So an aggregate entity is going to return another entity. Brewer, I'm not going to go through this because that's just another example of how to store it. You guys can see this in the slides later. Sorry, it's slow. But yeah, I mean, the reason we're using value objects is so when you call get full name or get email, you don't have to worry about checking that anywhere. You know, the email is always valid. So changing values, you know, you're gonna whatever the domain experts call it. You know, if it's changing email address, an example of a brewer, you know, call the function that. In your recipe, you know, it's add grain. Have a function called add grain and pass a grain entity or pass you know, a grain value object there. Remember the bounded context again. The recipes, inventory, and brewing house bounded context. You may have multiple grain entities throughout your system. So you have recipe grain, you have inventory grain, you have brewing session grain. They're all different. Don't try to use one object across your entire system. Like I said earlier, brewers are entities, but they're part of a supporting bounded context that you're going to see everywhere. The aggregates that I mentioned, kind of going through this quickly, but you know, they're the ones that manage child entities. I kind of already went over those. Building entities is, you know, you guys probably saw these, the first things you saw were the, you know, grain and recipe. The aggregates are the easiest to identify in your system. You know, recipe is pretty easy to find. You know, you're obvious that, you know, recipes are going to be needed. Modeling the other entities, the child entity, is a little bit tough. You know, that can be difficult. You know, do we have a grain entity? You know, or do we need to, you know, how we have to model it? That's really where the rubber meets the road when you're trying to figure out the modeling. But again, your names come from the event storming session. So a aggregate, you know, a recipe, if you're using doctrine, it's going to have this big annotation with the grain, you know, relation and stuff like that. Laravel, you're going to have, you know, the array and things like you're mapping to. But I don't want you to think about storage anymore. We're done talking about storage. You know, let's just look at a regular aggregate. And you know, like I mentioned, you have grain, add grain. Now, you can just store that in an array. But you know, think about, you know, what possible business rules could you have with, you know, adding grain to this entity. Well, there's this thing in brewing that you have to have a minimum amount of diastatic power, and that was that degrees Lintner value that I mentioned earlier. And if it's less than 40, the recipe will not work. It's an invalid recipe. So we can actually throw an exception in our function here that the grain is not valid. Now, if you're passing grains in to the constructor, you could validate it there. But you can do the math right here in your entity and throw an exception. Now, what I would recommend, like I said, is put as much logic in value objects as possible. So, instead of doing this method in the entity, let's create a new value object called a grain bill. And that's how brewers refer to the amount of grain that's going to go in a recipe. So we create an immutable array of objects. Again, value objects are immutable. And all of the grain objects would then be immutable inside of it as you're holding them. And you add a grain, and it can do the math right there. So your entity becomes much, much simpler. Again, all you're doing is holding collections and holding on to it. So add grain, it just calls this grain's add grain. And remember, that's a value object. It returns a copy of it, a new copy of itself. So you set this grain's equal to it. And that becomes your array collection. And Dr. Laravel knows how to persist that. So again, if you have a logic in an entity, try to move it to a value object. And as I mentioned before, the aggregates are your transactional boundaries for database transactions and stuff like that. Again, you can read a lot more about that. But I hope you're seeing that this kind of code that you're doing is much more maintainable, much more modifiable. This kind of gets to a user experience point. Now, we've done all this event storming. We're building our objects with the naming and stuff like that. It's going to force you to stop thinking about the data. Now, I'm kind of an application designer as well. This is what they call a task-based user interface. Now, if you've seen the HBO show Silicon Valley, Pied Piper had what they call the programmer's interface. Every switch, knob, bevel, everything on there possible that you could possibly want to change. And this user goes to use this, they're totally confused. But this lets you, if you're thinking data first, this is the kind of interface that you build. And this is an example I built for a library system. And when a librarian would go to use a library system, they don't think about editing a book and deleting a book. That doesn't make any sense. Your functions on a library system are like renew a book, return a book, replace a book, things like that. These actions that you guys wrote, these commands, those are the things that people think about. Those are the buttons that should be in your software. That's going to map directly to your functions on your entities. So when you're thinking about it from the events, you're thinking about the entities, you're thinking about the bounded context, the ubiquitous language. It's going to force you to build better software. You're not going to be thinking about the data first. So usability goes up. DDD has very little to do with security. Again, that's like a concern for every application, but DDD is just a layer as far as security is just a layer as far as DDD is concerned, unless that is your domain. But for the most part, most of us are just putting security in as a layer. And DDD, there's different ways of calling this: layered architecture, onion architecture. The DDD way of saying it is hexagonal architecture. And the idea here is that your controllers and security and templates are a very thin layer on the outside. And your core domain business logic is what you focus the most on. And let the framework do the outside pieces as much as possible. Like I said, don't build your own, login controllers and things like that. Let the frameworks do that for you. Focusing on that core domain is what you want to spend your time. I've been at the same company for 10 years, and doing code maintenance and that kind of stuff is not fun. And I felt like the first few years I was working there, I didn't realize it, but I was digging my own grave. We built software that we built fast. We built, with using CRUD apps and stuff like that. Now we're trying to maintain it. Much, much slower to maintain over time a CRUD app than it is to maintain a DDD app, because everything is encapsulated in the DDD apps. And it's much easier to understand when you go back and look at it 5 years later. If you work for a consultant agency and you hit it and quit it, whatever. You probably don't have to worry about this stuff. The other reason to do this hexagonal architecture and try to separate things as much as possible is, the frameworks change much, much faster than your domain logic. The brewing logic that you're going to write today, that's going to be good for, I don't know, 1600, started brewing in 1600s. It's probably good for another 500 to 1,000 years. Symfony or Laravel, Symfony is going to change every 6 months. Laravel changes whenever it changes. I don't know. But, to keep up with that, you're going to have maintenance to do on the framework and the controllers and things like that. You want to keep that separate from your domain logic. You don't want to tie your domain logic to your framework code and things like that. You want to keep it separate, keep it namespaced, and stay away from your domain logic. I'll point you to a talk by Matthias Reyes. He gave it at Laracon in 2014, decoupling the model from the framework. And I'm going to post these slides up later on the joined in. Ruby Midwest, Uncle Bob Martin has a great talk, Architecture of the Lost Years. Another one you should watch, definitely, about keeping your domain logic separate. The gist of that is, if you open your folder of your code, and this is the example GitHub project I have for this workshop, and you probably can't tell what it is necessarily, but when you open the domain folder up, you should sure as hell be able to tell what the software is doing, versus organizing everything into entities and controllers and repositories and things like that. Like, if your code is organized like that, you look at those folders and you have no idea of cohesion across the entire app. So again, thin controllers, persistence, things like that are all helping to the outside. You have an event bus and a command bus maybe that kind of taking application services. You have those kind of things. It's impossible. But like I mentioned earlier, the ports and adapters. Try not to have your domain logic depend on the framework. Try not to have the framework depend on the domain logic if possible. That will definitely help with your maintainability. All right, so a couple more things to mention just to get you going to the DDD. Domain events. Those are just basically immutable value objects, part of the core domain. When I had you write the orange things, I had them write them in the past tense. An event always happened in the past tense. When you put it in your software, it's already happened. It's not possible to have an event that's scheduled for the future. That's not an event. You can create them in entities. That's fine, as it's happening there, but they don't contain the entities. So you're going to map values out of the entities into value objects and store them there. The example was brew session was planned. It was one of the events that maybe another context is caring about. It's going to pass it. You take whatever you wrote in your orange code, smush it together like one big German word, and brew session was planned, and that becomes your event class. So like I said, they've handled the naming for you. And those are just big composite value objects that you're going to pass around. Everywhere in the system, you can depend on this event. Everything is good on it, no checking. Kind of repeating itself, but you get the idea. If you're asking yourself, where do these events come from right now? Most of the time, you're going to come from your entities or from services, or maybe just somewhere in your application layer. One of the things I like to do with entities is have this trait that we use. It's called event recorder. And all it does is hold an array of events. So that way an object can, as you do things in the object, you just hold that array of events. And then the controllers are using that entity can just ask the entity, hey, what events happened? And publish those up. So an example of that is like the yeast starter. We talked about building a yeast starter before it goes into the fermenter. Event recorder, the constructor of that will create an event. Yeast starter was made. Big composite value object. Record it. Wherever you're using that, you're creating that new yeast starter, then ask it for the events that were created and publish them back up to your application. When the yeast starter is finished, you're going to measure the specific gravity so you can figure out how much yeast you created. You're going to record that it was finished, and you're going to publish that up. Because maybe somebody cares, maybe somebody doesn't, but you might as well publish the events. So if you're looking at a controller or service or wherever you're doing this logic on your entities, and you have a function that's maybe creating it, like I said, you're going to create the new entity that you're doing. You got to persist your entity. If you're using Doctrine, you have to flush it. Everything should be persisted and flushed before you fire the event, because other pieces of the software you don't know where they're going to be are going to rely on that data to be there. It has to be there. You don't know that someday you might decide, oh, we can't publish our events right away and act on them because it takes too long. We're going to push them to a queue. Well, if you've persisted your entities before you publish, you don't have to worry about that because it can happen later. It's not a big deal. So yeah, just use an event publisher that comes with your framework and publish the events. And then you'll build listeners, like I said, and that is other bounded context. You have a listener that just listens for this event to come across the stream. And maybe in this case, it's a inventory automatic purchasing listener. So it's going to say, oh, brew session was planned. We better make sure we have all the grain handy and order it if it doesn't. And again, your value objects make this kind of stuff, kind of a lot simpler. This could be a very complex piece of software, but we can distill it all the way down to a value object that's a minimum grain order and make sure, oh, if it's less than 0, it's not possibly even negative. We have a lot of things that are all happening because these value objects are doing the work for us. Using domain events, passing around messages and stuff like that make things a lot more modifiable. All right, so there's other things in domain-driven design like specifications. Building business rules in a specification. Like I mentioned earlier, you know, you may have grain that you have a certain amount of degrees Lintner that's required. So if you look at your grain bill for a piece of recipe, you're going to store this in the database. You have all these float values and stuff like that. And you want to build a repository that's going to return you grain that's possible to self-convert, stuff like that. You're going to use these specifications. The specifications are basically business rules distilled to a class. And that's going to return a yes or no answer. And you're going to use those. And we can do an example real quick. If you flip through your packet there, you see I have like a, what is it? Minimum diastatic power specification. Now, that's probably going to operate on a grain. And I don't want to spend any time filling this out. I kind of didn't plan that very well. But you know, that specification is going to return a yes or no answer. So the repository, you don't have to build these queries into your repositories necessarily. If you have a very small data set, you don't need to build tons and tons of criterias and queries and all kinds of stuff in your database. You can just return all the grain and then filter through a specification and filter that down using a filter class. And you know, specifications become more important as business rules become more complex. So we'll have specifications that rely on other specifications. So a constructor of a specification may have 5 specifications with it. And you know, we just use that giant one in one place. We say, yeah, is this satisfied by this specification? Now, if the business rules change, we don't have to go and update the controller code and all of this stuff. We just update the specification. You can test that a lot easier than trying to end-to-end test everything. Specifications are a very important thing. So everything is awesome, right? You guys are feeling it? You're feeling the vibe? Anybody have any questions on the entities and aggregates and stuff? No? Both, actually. Yeah, so a good example would be like brewer was fired, say, right? There might be application concerns, like we need to clear his sessions. You know, we need to log him out immediately. We need to you know, delete his account from the directory. We need to delete his open directory account. We need to do things that are like infrastructure concerns. Then there's probably domain concerns as well, like, oh, he's in the middle of a brew session. We need to let somebody know to take over because you know he was responsible for this, but he's gone now. So you're going to have both listeners on both sides. Yeah, and you want to make your listeners. You don't want to have one listener that listens for brew is fired. You may have 5 listeners, so you're kind of spreading out the logic in every bounded context. You'd have a separate listener that's listening. Yeah. Yeah. Yeah, I mean that's going to be a business type rule. So you're gonna, so you know, if you have that problem, you're gonna have to notify somebody or something like, you know, or you could throw an exception. I mean that could be the case that you know, you're, you know, when you have a controller, at least if you're doing stuff in your Laravel, you can wrap that on a transaction and you know, throw an exception in your listener, and the transaction won't, even though you've flushed and persisted, the transaction wrapper around the whole thing will make the whole thing blow up all at once. Yeah, and that's kind of, there's some, I didn't cover this at all, but there's something when you get kind of further into the domain-driven design stuff, they call it sagas or process handlers. And it's basically a way of mapping out that kind of business flow where it's like, okay, yeah, we got to make sure this is in place. That, you know, the example is like a McDonald's or a Burger King when they're making your sandwich. They got to make sure you have the bun, the hamburger patty, the cheese, the lettuce. They don't have to make all of those at the same time. Or Starbucks, for example. You know, the process can be done in parallel, but it all needs to end up at the same place. So you're kind of dealing. You can do those kind of. You can model that, you know, in a class to make sure that this needs to happen and this needs to happen. If it doesn't, throw an exception. Catch it. Okay. We have about 10 minutes. I want to cover 2 other subjects that, as soon as you get into DDD, you're going to see. And I don't want to I don't want you to be totally confused or assume that you need to run out and do this stuff because it's designed for very, very large apps. So again, DDD, it's, you know, the people from enterprise software people are liking this a lot more than your, you know, small software development shop. you don't need to do these things, and one is command query responsibility segregation, CQRS. You don't need to do this unless you have a very big app and you have a lot of complex stuff. But a lot of people, they see fancy ways of implementing or fancy frameworks, and they want to jump in and use them. They call this CQRS, and it's a fancy way of saying we're going to keep the write side separate from the read side. Now, what you end up is you have write models and you have read models. Your write side becomes more of your domain model, and your read side becomes projections. And you kind of can separate what it is to see like a list of grain separately from everything you could do to grain. So you don't have to, when you're building your views and things like that, you don't have to worry about all the functionality that can happen. You can just read from the database and display it. And if you have a large team or a big product or you need to cache data and things like that, the CQRS may help with stuff where you're building projections of data and you're trying to cache it. The way that kind of works, and this is kind of like together, command query, response declaration, you have a controller and you have a command bus. The command bus is kind of separate from the controller. And as a request comes in, the controller handles the request, creates a command, which is a value object, sends it to the command bus. Sorry, there's the command. You guys did the blue squares. Those are your commands. If you're doing CQRS, those become your command objects. If you don't do CQRS, those should become your method names. Add grain, add hops, things like that. Those, again, are value objects, composite value objects. So the controller passes that command down to a command bus. Command bus figures out which handler, which is, again, just like a listener, fires the command to that, figures out the response, passes it back up. The idea here is that you can have really, really, really thin controllers, because all you have to do is take the user input, figure out a command. The command is valid. I mean, it's like that. The example I just had, all those are value objects. It's impossible for it to be invalid. Command bus, fires back the response. In the slides here, I have a link to go learn more about that. But the idea is, that these very complex controllers, you can eliminate down quite a bit. I put a diagram in the packet as well, as kind of like a flow chart as far as how that falls through your software. Again, I don't want to talk about it because it's very complex. Again, why would you want to do this? Well, having those really thin controllers makes it easier to keep your domain logic separate from your framework. You want to switch from frameworks. You want to make the changes that. It's very easy to change. If you have many, many ways of doing the same thing, so if you have an iPhone app and a web app and a console application, various, many, many versions of an API, and you want to do the same thing in multiple places, commands and command buses make that a lot easier, because you build your command, you fire it off the command bus. All of your domain logic is in the handling side. There's no logic in the controllers and stuff like that, so it becomes easier to do that. All right, one more thing, and that's event sourcing. And that is basically a way of storing models and data that's different than most people are used to. So it's not database tables that are spread across. Does anybody play chess here? Yeah? All right, so you guys are probably familiar with this notation, but there's a notation for chess that you can play back any game in chess, and you can play it to any point and see what the board looks like at that point by following the notation. If you look at a bank journal, it has credits and debits. So at any point, you can figure out the balance by following the credits and debits. As software developers, you're probably used to seeing like Git diff requests. Git doesn't store like every copy of every file that you've ever had. It stores the differences between over time. That's basically what I'm talking about with event sourcing, is that you're no longer going to persist your event properties. Your events are persisted to an append-only event storage. So your object, like your grain object, you're not going to store a name, a quantity, those kind of things. You're just going to store the events, like the name was changed, the quantity was increased, the quantity was decreased. And you're going to, by looping through those events and replaying them, you're going to be able to figure out what the current state is, or what the state was at any time. Reasons to do event sourcing, it avoids a lot of data mapping because you're just storing events. You don't have to, if you have a recipe, you don't need a grain table. You don't need a hops table. You don't need a yeast table. You don't need all these other tables that you would need to store linked, associated models with. All you have to do is store the events. That becomes one table associated with your recipe. And you potentially reduce model counts because you don't need to store all these as models. You can store them as value objects, as events. And there's a couple of libraries that are PHP libraries that are good. for doing this. But I kind of wanted to do an example real quick that is in the GitHub repository. You can go look at this. But it's in the kind of the second to last page, I think, or third to last page of your packet there. And if you look through that, you'll see that basically you just loop through those history events and replay them, and you call a method that knows how to set the internal variables of that object. And all you have to worry about storing, if you're going to persist that object then, is the event stream. So you need a recipe table that might store the ID. That's it. And then you have a recipe events table that you're storing everything in. If you're using NoSQL database, you just have one big blob that is your recipe, and it's going to have all the events associated with it. So storage really does not become a concern then at all. It becomes very, very easy. What becomes difficult is that if you have many, many recipes, many, many events, and you're trying to read that data, like you want to display a list of recipes and all the solution, what's happened. You don't necessarily want to have to load the recipes, loop through all the events, play them back. You're talking about, complexity. If you remember big O notation, complexity getting worse and worse and worse as you have the objects. If you have 10 recipes to display, and each one of those recipes has 10 events in the past, you have to load 100 objects to load 10 recipes. Obviously, that can get way worse. So you can cache it, you can do things like that. But that's where the CQRS and event sourcing kind of come together, is that if you're going to do event sourcing, you probably want to build read projections that make your application fast. So you're going to want to store a cached copy of all your recipe names and maybe a few details about them. So to do event sourcing, only do it in things that are very complex, or care about that entity over time, because you get logging for free. Your event stream is your log. But again, if you start reading material on DDD, they're going to push you towards CQRS and events sourcing. You don't need to do it for most applications. It's only for big, enterprise applications. I know I'm a little bit over time here. Learning more, again, if you want to learn more about brewing beer, homebrewersassociation.org. The Reddit homebrewing thread is really good. Go visit your local homebrew shop. I have mine in my phone as a favorite. They're great, always a great resource if you have one nearby. More importantly, if you want to learn more about DDD, all these books are great. I mentioned earlier in the beginning, you can find them on Amazon and whatnot. A couple of PHP developers that I know did a podcast where they ran through, they have a couple different books that they've gone through, but they went through the Red DDD book, every chapter, and had a discussion about it. It's maybe about 12 hours, 14 hours total, but if you start looking through the Red book, watch this dev book club goes along with it. It's like having a book club. I mean, if you've ever done that before, you really get an understanding of DDD from watching that and understanding it. A couple of podcasts that you can go watch about DDD. They've different episodes. There's a conference called Domain Driven Design Europe that has all their videos, their sessions are online. If you want a much more in-depth workshop, this is kind of a high level, we'll talk about it for 2.5 hours, do a few things. I would have wished I could have done more examples, but we took longer than to do a few things. I talked way, way too much, as everyone knows I do. But if you want to go for a couple of days, Von Vernon, the guy who wrote the Red Book, runs workshops. And these are all international right now, but he does plenty in the United States as well. And it's a great way to learn more about it. There's a couple of GitHub repositories that are great. The Friends of DDD State of the Union is a great one. Has a bunch of example projects, like full end-to-end projects to get you going on DDD. Awesome DDD, again, another list of things that you can learn more about, that kind of thing. If you have questions, there's a fantastic Google group, DDD and PHP.org, that just takes you to the Google group. Fantastic answers, questions on there. If you have a question, search in there first. You'll probably find your answer. But again, you can always reach out to me on Twitter or on my website. You can get my email. Leave you with a couple of final thoughts. I can't teach you everything about DDD in 2.5 hours, just like I can't cure your slice in golf in 60 seconds. It's actually not possible. You're going to get better by working together with stakeholders, working with other developers, modeling. If you don't have other developers you work with, teach your dog about DDD. You learn more by teaching. It's probably my fifth time speaking about DDD. I learn more every time. If you don't have a dog, you can talk to your elephant. They don't, they remember everything. So Have one of these on your desk, and when you're thinking about code, verbalize it. It just makes for much better code, better understanding. Reasons why you should learn more about DDD. Autonomous cars, primarily, first reason. No. CRUD applications are dead. I mean, how much longer can it be to generate a full application that just reads and updates and deletes data? That AI is going to have that crap figured out in a couple of years. Don't worry about it. So having better skills, having more advanced skills, understanding and being able to solve problems that are complex, that a machine may not be able to figure out, that's going to be your value for the next few years. Value objects, value objects, value objects. Avoid common pitfalls in your program. I mean, how many times have you had a bug that was tied to a value that you didn't validate properly? Value objects, big deal. Separate your code into bounded contexts. Keep things separate as much as possible. You'll much easier. If you're dealing with legacy, keep legacy away from your bounded contexts. The easiest way I found is you're publishing events from legacy that are new value objects. So you publish a domain event from legacy to talk to the new bounded contexts. Don't try to wrap legacy code, maybe, especially in my cases, legacy code that's not dependency injected properly, it's not written properly, it's using old ORMs and things like that. It's not possible to move this over to a dependency injected proper way of doing things. So pass messages tends to be the easiest way to get stuff between things, whether it's done through an API or call or whatever. How many of you have seen the Agile Manifesto? Yeah. Okay. So everybody hears Agile with capital A, registered trademark from Jira. But the real way that you're going to have a better way of building software is being agile. And if you look at the actual manifesto, and this is kind of getting cut off because of the projector, but valuing the individuals and interactions over process and tools. We've talked a lot about ubiquitous language today. We tried to go through how you can build the ubiquitous language with your people that you work with. Value that over the frameworks and the implementation that you build. Working software over comprehensive documentation. The ubiquitous language and mapping those directly to entities, mapping those methods to those names. You don't need to document it. The brewer can read your code. You don't need to write a bunch of documentation that goes along with it. And again, customer calibration and responding to change. Those are making your software more modifiable, more maintainable. So I covered a lot. I talked a lot. And I know you guys probably have more questions, and I'm happy to answer them afterwards, but we're kind of out of time. I wish I could have done more examples. Kind of ran out of time, so I skipped a few of them. I had them out, we could have done. But I'm happy to run through any of those after, if you guys want to do some coding or anything like that, I'm happy to stick around and go over more. But does anybody have any questions? No? Yeah. 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 Start building value objects that are gonna. You might be able to use those in a legacy code because those are going to come in easy. There's no dependencies for them, so you're gonna be able to start using those right away. Yeah, if you have a process, fire an event, and a new code that's reacting to that, build a listener, and then build your model off of that. We have that exact problem. We're sharing code sharing database tables between legacy code and new domain code, and that's our primary pain point. Is that legacy code didn't validate something. So, like in the case of a brewery, example, maybe we didn't validate the brewer's full name. In our domain, we had setters, so it just said set. And for some reason, somebody's name we didn't know who it wasn't set. Well, the new domain model expects all of that to be there, so we end up having exceptions because we're looking at data that's invalid. Now, it's proper that's an exception because we can't proceed. We don't know who it was. So we stop there and we halt, the code halts. But that's our primary problem is that, trying to share model and background stuff with the legacy code and the new code becomes difficult. If you're going to share data and you build a new model, one of the things we'll do is, like, part of our migration process is we'll actually read every entity out of the database and make sure that it can be rehydrated and operated on. making sure that we're basically validating all our old data going forward that way. So, example would be find all the brewers in the brewery, loop through each one, call get full name, get, because that's going to force it to go through the constructor process, the value objects, and it's going to validate everything. It's the only way to guarantee that you're mapping old legacy code to new domain. Yeah. Yeah. You can make a value object called middle name optional, and they could be set or not set. It could be empty string. You can deal with that way. You can have multiple constructors. So I mentioned that static constructor thing. You could have a full name that's first name and last name constructor. You could have another constructor that's first name, middle name, last name constructor. It all creates full name objects. So now you're dealing in full names. You're not worried about first, middle, last being there. But your optional parameter constructors handle that. It's common with like email addresses and stuff like that, where you may not have data. Avoid nulls if you can in your code. I mean, you'll have less problems that way. Okay? Thanks, guys. I appreciate your feedback. And I have a lot more candy. If anybody wants any of those nut rolls, you guys suffered enough, so you deserve one. But thank you.